Integrated. All right, integrated math guys. I don't know how to speak apparently. And I think you guys would think that's funny, so I'm not going to edit it out. And I'm not going to re record. Because why not allow it? Remind me tomorrow. Why not allow you guys a little laugh? Here's your quick study guide video. Right? The first part is just simple FOIL. FOIL. Remember FOIL? FOIL. FOIL. All right. Firsts, outers, inners. Whoops. There we go. That's better. And lasts. And all it means is if you have a couple of binomials. Binomials, sir, that's math language. This is integrated math. We don't talk like that. We're not going to be engineers. Whoops! I made a mistake already. I didn't have you guys to help me. You guys always yell at me when I start making a mistake. You always catch me. There we go. All right, so I think I'm going to change the color on these guys. I'm going to make this guy, yeah, let's do that. Let's make him pink. You guys love pink. I'm going to make this guy, this O, which is the hardest one to trace, right, is the O. I'm going to make that O red. There we go. And then I can show it to you a little bit easier. And I'll make that, what is that, green? There we go. I guess we can leave the yellow alone. Okay, so let's go to the first pink. We're going to multiply this and this, right? So we're going to multiply. What? This is supposed to be a y. Y times 3y. Okay. Y times y times 3y is 3y squared. And then you got to move to red. The outsides. So it's y times 2. Well, that's super simple. That's just 2y. Right? And then green. Whoop. And that's 6 times, I forgot to put addition symbols in between everything. 6 times 3y, and that just means it's 18y. And last but certainly not least, the lasts. Oh, poor little lasts. Okay, 6 times 2, and that's 12. I'm going to write the actual, here's what we did, 6 times 2, which is 12. Now, in the middle, my Christmas colors, says the Jew. I mean, says Mr. Sokol, who happens to be Jewish. Those two things are like terms, so we're going to put them together. 2 plus 18 is 20. Y. And then we just bring everything else down. 3y squared plus 12. We're all done. That's FOIL. So you do that a few times, and then we move on. The next part, the next thing the next idea you're going to work on or work with, or however you want to talk about it, is percentages, percents. Am I in the right color? Sure, we don't mind this. Percents. All right, so there are 3 types, right? And there are only 2 on this test. there's what is this percent of, and then there's we get the number, and 480 is what percent? What percent, right? So this is more like 30% of 70, you know. All right, so let's go ahead and do these. I'm going to clear this out and we'll do it right. Number 1 says, what is find, maybe it's lost, find 35% of 31. And so what we do is we turn 35% into a decimal. And remember, it's 35 out of 100. So it's 35 hundredths. Well, how do we write 35 hundredths? Anyway, we write 35, and we take the decimal point back here, and we move it up 2 spaces. So that means it's 0.35 of means multiplication 31. So if I take out my handy dandy calculator and I say 0.35 times 31, I get I get 10.85. All right, not a big deal. There's another one just like it right below it. And then the last one, what is, it says 480 is what percent of 1200? And so all we're going to do is we're going to put 480 over 1200 and do that division. So we put into our calculator 480 divided by 1200, and we hit the enter button. And what we should get out is a decimal. And we do. We get 0.4, and let's rewrite it over here. 0.4. Now, remember, when we turned our percent into a decimal, we moved the decimal 2 places to the left. So if we're going to take it from a decimal back to a percent, we're going to move 2 places to the right, which means 1, 2. Now, if there's an empty space, I have to fill it with a 0. So my new number is 40, so it must be 40%. Sound good? And that's it. And if you look at it, it seems pretty simple. 40%, 4 over 10. It's pretty good. So I'm going to move on because you guys are tired of me talking. And this video is getting longer than I told Michael it would be. So let me get rid of this. There are only 2 other things I need to talk about. And it has to do with the second page, right? I have to create and label, right? I need to create and label a triangle. And then after I create and label the triangle, what I'm going to do is I'm going to do a problem that has to do with that triangle. So let me create a triangle and label it. Here's a right triangle. And if I start here and go out here, there we go. And last but certainly not least, bring it up here and touch the end there. And looky, I have a right triangle. Whoopee, whoopee, whoopee. And if we're looking from here, if this is our point of view, make believe that theta is like a little face, you know, a little smiley face, looking up this way. And it looks lovingly across the street. That's the side opposite, right? And it looks lovingly now at the side that it's next to. And that's the side that's adjacent, next to, right? And then this, the slanty side, that's the hypotenuse. And let's see if there's anything real cool I need you to say on the test, or if we can just label that sucker and be done. Oh yeah, so basically what you're going to look at and what you're going to try and write down on the test is the hypotenuse is the side that's across from hypotenuse is the side across from 90-degree angle. The adjacent side is side next to the reference angle, the angle that you're given. So wherever they put that theta or that angle measure, like in this problem, they use 65 degrees. Wow, I cannot talk today. All right, and then, so that's adjacent, is right across from it. Sorry about that bell. And then I'll change colors again, and we'll say, let's make something really jump out at you. Then we say opposite is side across from reference angle. Okay, and that's what you're going to basically write to a certain extent on your test, and you should be good. And then I'm going to show you that problem. So let's go ahead and undo this. So if you guys need to, you can go back to see it. I'm going to undo this. I'm going to get rid of this nonsense. I'm going to use a really bright color just to tick you off and make a triangle. Here's my right triangle. And bam, bright color. You guys know I'm weird, right? Bam, bright color. I like this color. This color goes well in this background. So there it is. We are given an angle, not quite as excited about this color, of 65 degrees. We're given that the length of a string, oh, that's not the length of the string, you dork. Or maybe it is. It is, okay. The length of the string is 25. 25 meters. Oh my gosh, what is this, physics? Oh, you guys are going to be so sad. It says how high? How high? how high is the kite? Well, I can sort of draw a kite. And there's its little tail. Okay, there's the kite flying in the air. How high is the kite in the air? Well, okay, well, I want to know what the opposite side is, and I'm given the hypotenuse. Well, if I'm looking at that, I want to know the sine, because sine is opposite over hypotenuse. I didn't tell you that in class, so don't get mad at me, but go ahead and watch this, and I will check in with you guys. So the sine of some angle is going to be equal to the ratio of the opposite over the hypotenuse. So sine of 65 degrees, that's our angle in question, 65. It's about how old I am. Not really, but you know, that's what you guys would think. Would be the height in the air of the kite over 25 meters. Well, how do I get x by itself? I just multiply both sides by 25, and here's what happens. I get 25 meters times the sine of 65. Now, if this were some other value, I'd be able to get there real fast, but 25 sine 65, close parentheses, I better be in degree mode, is to the nearest meter. So it's, put that in, you get just about 23 meters. Just about. Right? And that's it. The only other thing is what I showed you today. I showed you how to solve two-step equations. It's just reminding you how to solve two-step equations. Not a big deal. You can handle this. Let me scroll because I'm looking at your test right now. I want to do something. Oh, so I'm going to do the more difficult one first. I'm going to do the one that has some distribution first. And I'm going to show you that they both end up looking the same. If you have 3 times x minus 4 equals 15, you can do it one of two ways. You can either, to get rid of this, divide both sides by 3, but that looks a little scary, or you can distribute the 3 and then do the math. Okay, so let's go ahead and distribute, because you guys are used to distribution. It's like FOIL, so let's go ahead and do it. So 3 times x is 3x. 3 times 4 is 12 equals 15, okay? And so this looks very much like the other one that's sitting next to it, so I'm going to do them both at the same time. 4x minus 3 equals 9. If you solve them the same way, you do, by the way, so you simply add 12, you undo the addition or subtraction, so you get rid of that. And that means you add 12 to this side as well, which gives you 27 equals, bring this down, 3x. So let's do the same thing. What is being added or subtracted to my variable value? We're subtracting 3 from it. So let's do the opposite, because that will get rid of it. Plus and minus, they get rid of each other. Well, if I did it here, I have to do it over here. So that's 12. All right, 4x equals 12. All right, so we just have some multiplication to undo here. So if on this side, I didn't use this yet. On this side, I'm just going to divide by 3. That's too light. I mean, I can't see it. Let's go with this guy. I'm going to divide by 3, divide by 3. This turns into 1, because 3 divided by 3 is 1. So 1x equals 27 divided by 3, that's 9. This one x is being multiplied by 4, so we're going to divide both sides by 4. That becomes a 1. So we have 1x equals 12 divided by 4, which is 3. Guys, that's it for your study. You should be good. We went over the other page in class. Let me know with an email if you have any questions. Or a message on Google Classroom. You know what I mean. Thanks. Bye.